Good morning, everybody. Today we are discussing the next topic of the instrumentation electroanalytical method, that is the glass electrode, which is used for measuring the pH of the analyte solution. As we discussed earlier, the glass electrode consisting of the two electrode. First one is the glass electrode. The second one is an reference electrode. We can use calomel electrode as a reference electrode, and these two electrodes are dipped in an analyte solution whose pH has to be determined. As we discussed earlier, the glass electrode consisting of a membrane and which is dipped in the analyte solution, and the one side of the membrane, that is, it is shown by the inset here. So here we can see that in the inside of this glass electrode we have a silver wire, and it is filled with an acid solution, and there is a thin glass membrane in the tip of the knob of that electrode, and which is dipped in the in the solution, analyte solution. And now when we dipped in the analyte solution, if it is an acid, definitely it contains H plus ions in the analyte solution. This H plus ion is interact with this membrane, and the H plus ions is make a bond with the weak interaction with the membrane of the glass electrode. And similarly, the other side of the membrane is also in contact with the H plus ions in the HCl. So due to this interaction, there exists a potential difference between the two sides of the membrane. Thus, we can measure the concentration of the H plus ion in the analyte solution. These are the one of the important application of the glass electrode, and the main application it is used for the measurement of the pH. And what is the properties of the glass pH electrode? First one, the potential is not affected by the presence of an oxidizing or reducing agent. We can use any medium if it is a redox system, and it operates over a wide pH range. We know that the quinhydron electrode, it is used as a reference electrode, but we cannot use that quinhydron electrode for the high basic condition. But glass electrode can use a wide range of pH region, and the response is very fast, and it will function well in physiological system, and it is highly selective, and it is a long span electron. And next is the theory of the glass membrane potential. So consider the glass, and as we discussed earlier, the membrane has two sides. One is filled with an internal solution. We know that the internal solution is a 0.1 molar HCl solution, and definitely it contains H plus ion, and this H plus ions form a weak interaction with the O minus ions in the membrane. And the other part of the membrane is in contact with the external solution whose pH has to be determined. So definitely that solution contains H plus ions, and that H plus ions form a weak interaction with the O minus ions. So due to this H plus ion on the both sides of the membrane, the potential difference is developed, and that can be measured. Thus, we can find out the potential of the analyte solution. So, for the electrode to become operative, it must be soaked in water. So, every pH meter, we know that every pH meter, the electrode of the pH meter is always dipped in a water. This is mainly due to for hydrating that membrane. And during this process, the outer surface of the membrane become hydrated. When it is so, the sodium ion are exchanged for the proton in the solution. So protons are free to move and exchange with the other ion. So how we will determine the potential? So we have already studied the Nernst equation. Nernst equation is that potential E of an electrode is equal to E0, that is the standard potential of an electrode, minus 0.0591 into log concentration of the H2. Here it is 1 divided by the concentration of the H plus. That is the general Nernst equation. So if we apply the Nernst equation, we can write like this: Eg is equal to E0 of the standard value of the glass minus 0.0591 into ln H plus. So we know that minus ln H plus is the log H plus is the concentration, the pH value. So we have to substitute, instead of minus ln H plus, we can substitute pH. So Eg is equal to E0 plus 0.0591 into pH. So E cell is equal to EC minus Eg. So EC minus E cell is equal to Eg. So thus we can easily find out the potential of the glass electrode. And finally, we can measure the pH of the analyte solution using this equation. Thank you.